Welcome, Hornets, and thank you for joining me today. We're going to be taking a look at solving differential equations of growth and decay. This is coming from section 6.2, found on page 394 from Early Transcendental Functions Calculus, AP Edition 6E. Alrighty, let's just take a quick look at the problem so that individuals will be able to identify what it is we're working with. So in the first part, we're going to be solving the differential equation. Then we're going to be taking a look at the slope fields. And then we have finding a particular solution. This then leads us to find the exponential function. And then we finish doing just a sundry of problems that are working with exponential growth and decay as we go through toward the end. Now, I'm not entirely sure how many of these we'll be able to get done, but we're going to do our best. All right, so we're starting with number 1 through 12. And I'm going to start with number 1 being dy dx equaling x plus 3. Now, I always like to start off by writing it as if it were an FRQ problem, and that means writing down the problem exactly as I see it, followed by moving or separating the variables to the various sides so that I can then integrate. And all of these problems that we're going to do, the integration isn't too bad. You'll notice we get 1/2 x squared plus 3x plus c, and they don't give us a point, so all we can do is get a general solution. There's number 1. Number 2. Number 2 gives me dy dx, and dy dx equals 5 minus 8x. So we're going to separate our variables. 5 minus 8x dx. We're then going to integrate dy and integrate 5 minus 8x dx. We get y equal to 5x minus 4x squared plus c. We move on to number 3. Number 3 gives me dy dx is equal to y plus 3. We're now going to separate our variables again. 1 over y plus 3 dy equals dx. We're going to then integrate 1 over y plus 3 dy equals the integration of dx. We now have our x on this side, and I am going to put it as an x plus c. And on this side, we end up getting the natural log of y plus 3. Going to exponentiate both sides so that I get y plus 3 equals a constant e to the x. Now, let's just take a moment and go through this real quickly. According to my laws of powers, when I have some variable to the b plus c, it's the same thing as a to the b times a to the c. But notice that this is going to give me e to the x times e to the constant. But e to the constant is a constant, and so I write it as ce to the x. We're now going to finish by subtracting 3, and we get ce to the x minus 3. And this is my answer. Now, without having a point on the curve, there's no way for us to know what that constant is. Let's go ahead and take a look at number 4 now. Number 4 is showing us dy dx. And this is equal to 6 minus y. Separating my variables, 1 over 6 minus y dy is equal to dx. We then integrate 1 over 6 minus y dy equaling the integration of dx. And here, when we use our u sub, we're going to get a negative, and therefore we have the negative natural log of 6 minus y equals x plus c. I'm going to multiply my negative to both sides so that I get the natural log. 6 minus y equals negative x plus c. And now I can exponentiate. I get 6 minus y equals CE to the negative x. I'm going to add 6 to, or subtract 6 from both sides and then distribute the negative. We continue up here. So I have negative y equals CE to the negative x minus 6, and then multiply to give me 6 minus CE to the negative x. Now, I will point out that we could also write this as 6 plus CE to the negative x, and that's because the constant can either be positive or negative, and we don't know. So one of those two answers is what we're looking for. Let's go ahead and move to number 5 next. So number 5, we are looking at y prime is equal to 5x over y. I'm going to rewrite it as dy dx equals 5x over y. This allows me to separate my variables and then integrate both sides so that I end up with 1/2 y squared is equal to 5/2 x squared plus c. I'm going to multiply both sides by 2 so that y squared equals 5/2 x squared, and it's going to be multiplied by 2, so we end up with just 5x squared plus c. And then I'm going to take the square root. Now this is going to give me a plus or a minus, the square root 5x squared plus c. Now it's real important that we understand that if I were given a point, I have two possibilities. I have a positive radical and a negative radical. If they had given me a point that had a negative y value, putting it down here, I would use the negative square root portion of my answer. And whatever constant I got from that negative y would go back here. If, however, my y value was a positive, that means that I'm using the positive square root of 5x squared plus c, and plugging in the c is going to give me a value, and I end up with a positive radical. Now, this is the trick question that is on the AP test that you have to watch out for. And it is all based upon that negative that we have there. Alrighty, let's take a look at number 6, please. Number 6 gives me y prime equal to negative, we have the square root of x, and we have 4y. So rewriting it as dy dx equaling negative square root of x divided by 4y, I'm going to separate my variable, which means that I'm going to put my y dy equaling negative 1/4 square root of x dx. You'll notice I've got this set up so that I can integrate it cleanly. The integration of y dy equals negative 1/4 the integration of x to the 1/2 power dx. This gives me y squared to the 1/2, and I have, or 1/2 y squared equaling. This is giving me negative 1/4. I'm going to have 2/3 x to the 3/2 power plus c, and this is giving me 1/2 y squared equaling negative 1/6 x to the 3/2 power plus c. Multiplying both sides by 2, y squared equals negative 1/3 x to the 3/2 power plus c. Once again, the c does not change, and I then take the square root. This is going to then make it the plus or minus square root. I'm now going to write it as c minus 1/3 x to the 3/2 power. And this is my answer. Once again, not knowing whether we have the positive or the negative in this. This is going to bring us to number 7. Number 7, we have y prime equals the square root of x times y for dy dx equaling square root of x times y. 1 over y dy equals the x to the 1/2 power dx. The integration of 1 over y dy equals the integration x to the 1/2 power dx. This gives me the natural log absolute value of y equals 2/3 x to the 3/2 power plus c. We're now going to exponentiate both sides. As I exponentiate, I'm now getting y equal to my constant e to the 2/3 x to the 3/2 power. And there we have our answer. Alrighty, now all of these follow this same pattern, so let's check 8 next as we rapidly come to the end. Y prime equals x times 1 plus y, dy dx is equal to x times 1 plus y. Separating my variables, 1 over 1 plus y dy equals x dx. Integrating 1 over y plus 1 dy equaling the integration of x dx. The natural log absolute value of y plus 1 is equal to 1/2 x squared plus c. Exponentiating, I get y plus 1. Notice how the absolute values go away when we exponentiate. Please watch out for that. We end up getting our constant e to the 1/2 x squared, and I'm now going to subtract 1. ce to the 1/2 x squared power minus 1 is my answer. Let's go ahead and take a look at 9. Number 9 is 1 plus x squared y prime. So x squared parentheses y prime. And we have minus 2xy equaling 0. Alrighty, move this over so that I have 1 plus x squared y prime equals 2xy. Changing this so that I have dy dx. This is going to become 2xy, and I now have x squared plus 1 in the denominator. When I separate my variables, I get 1 over y dy is equal to 2x, x squared plus 1 dx. We integrate 1 over y dy is giving me the integration 2x over x squared plus 1 dx. This is a direct u substitution, so I do have the natural log of the absolute value of y equaling, this is my u sub, so I have the natural log of x squared plus 1 plus c. When I exponentiate, please remember this is now a product, and I have y equaling my constant times, and I have x squared plus 1. And that's my answer. Lastly, number 10, we have our x, y plus y prime equals 100x. And let's just move things over so that I have y prime equaling 100x minus xy. dy dx is then equal to x times 100 minus y. I then have 1 over 100 minus y dy equaling x dx. I then integrate 1 over 100 minus y dy equals the integration of x dx. This is giving me negative natural log absolute value 100 minus y equaling 1/2 x squared plus c. I'm going to multiply the negative on the opposite side. This is giving me negative 1/2 x squared, and I'm going to keep that as a plus c. If you wish, you can make it a minus c, but it's not that important. I'm going to exponentiate both sides. I end up with 100 minus y equaling my constant e to the negative 1/2 x squared power. I'm going to move the 100 over. I'm going to multiply by the negative. So when I get that negative 100, it's going to become a positive 100. I'm then subtracting CE to the negative 1/2 x squared power, and this is y. Moving on, we're looking at number 11. Now, please be aware, number 11 is where we start to use the language. All right, so let me go to it so you can read it and follow along with me. We're translating our language into the word problem, which they then want us to write and solve. So the rate of change of q with respect to t is inversely proportional to the square of t. All right, now we talked about that in class. The rate of change of q with respect to t, dq dt equals, because it's a rate of change is proportional, and it is inversely, we have k divided by the square of t squared. This is what we're looking for. Okay? Now, if I were trying to solve this differential equation, so this was a in number 11, I'm now going to separate my variables. So dq equals kt to the minus second power dt, integrating dq, and then integrating t to the minus second dt. Adding 1, I get q in terms of t is negative k over t plus c. And that's what they're asking us to find. Number 12. Number 12, let's now go to the words again. They give us, it's right here, the rate of change of p with respect to t is proportional to 25 minus t. And there went my lights, everybody. Sorry about that. This will be my last problem, and I'll probably do part 2 tomorrow. So we have the rate of change of p with respect to t is proportional to 25 minus t. Separating my variables, dp equals k, 25 minus t, dt, integrating dp, integrating k, 25 minus t, dt. I get p in terms of t is equal to k times 25t minus 1/2 t squared plus c. And let's just go ahead and call it p of t. And I have that equal to negative k over 2 t squared plus k times 25t plus c. And there's number 12. Alrighty, so this ends part 1 of the homework, and we have just covered numbers 1 through 12. In part 2, I will do 15 through 17, 21 through 23, and then we'll see about the 29 through 43 odds only. Alrighty, thank you very much, Hornets. Please be aware part 2 will be coming tomorrow night. So thank you very much, and if you like this and it's helped, please make sure you click like. If not, put your comments down. I do look for those comments in an effort to try to improve. Thank you very much. Be well and be safe. Good night, Hornets.